Okay, we're going to look at how to balance redox reactions using change in oxidation number. To do that, we follow a simple procedure. The first step is to balance the electrons being transferred between the reduction component and the oxidation component of the reaction. So let's take a reaction. Copper in its elemental form reacting with silver ions gives us copper ions and silver in its elemental form being precipitated out. First step, as we've always done, is to find the oxidation numbers of each of our components. So our copper in elemental form will have an oxidation number of 0, and it goes to a 2+ form, therefore the oxidation number on that copper is +2. Our silver, on the other hand, going from a +1 charge, must have a +1 oxidation state, going to a 0 oxidation state because it's in its elemental form. Now we can represent this in a table. So we put down our two elements. We have their initial oxidation state and their final oxidation state. So our copper starts at 0 and ends in +2. Our silver starts at +1 and ends in 0. So we write that down as well. We then look at the transfer of electrons. So our copper going from 0 to +2 has lost 2 electrons, change in the number of electrons. Our silver has gone from +1 to 0, so it's gained 1 electron. We then write down the number of atoms in our equation. So our copper has a 1 to 1, so we write down 1 atom. Our silver has a 1 to 1, so we write down 1 atom. This then gives us the total number of electrons that have changed in the two half reactions. So for the oxidation, the copper, going from 0 to +2, loses a total of 2 electrons. Our silver, going from +1 to 0, for each atom, loses 1 electron. So we can see from the number of electrons that are transferred and received that that doesn't balance. So we need to come up with a mechanism for balancing those two half reactions. And the way that we do that is look for the lowest common multiple for those two to give us a balanced number of electrons. In this case, we have 2 electrons, 1 electron. We're going to multiply through the first reaction by 1 to give us 2 electrons. And in the second reaction, we start with 1 electron. We're going to multiply through by 2 to give us that 2 electrons as well. We can now look at balancing our atoms through the system. So we do that by writing out our reaction again and using this multiple here and plugging it into our reaction. So write down our reaction. We see that we have 1 lot of copper going to 1 lot of copper. So we would have a 1 in there. On the other hand, we have 2 lots of silver. So we have to put a 2 as the prefix in for the silver plus ions. We also have that forming 2 silver solid ions, 2 silver solid atoms. So we write that in. We then look at balancing our oxygens. We don't have any oxygen in the system, so we don't need to do anything with that. We look at balancing our hydrogens in the system. In this case, we don't have any hydrogen, so we don't need to worry about that. Our fifth step is to balance our hydroxides if we're in a basic solution. We haven't got a basic solution, so we don't need to worry about that. So we can now look at checking our system. So we have our copper atoms. We have 1 in our reactants, 1 in our product. Our silver, we have 2 in our reactants, 2 in our products. And the last step is to have a look at our charge. So we have 2 times +1 here to give us +2 overall, and we have 1 times +2 to give us +2 as our charge in our products. So this reaction is now balanced.